It's easy to look at an L-handle socket wrench, toss it into a toolbox, and never pause to consider how it came to be. Sure, it's just a bent piece of metal with a drive on one end. How complex could that be? But if you dig a little deeper, you'll uncover a meticulous process involving red-hot steel, precision engineering, and a series of finishing touches that transforms raw metal into a tool tough enough to tackle countless mechanical tasks. Beneath the surface, you'll find an intriguing world of brand rivalries, evolving patents, material controversies, and even debates over whether the manual wrench's days are numbered in an era that increasingly favors powered tools. Still, the L-handle wrench stubbornly persists, celebrated by mechanics who swear by its reliability and do-it-yourselfers who value its simplicity. And once you glimpse the care and detail behind each bend and bevel, you might never see this unassuming tool the same way again. In its simplest form, the L-handle socket wrench, often just called an L-bar or spinner handle, is essentially a steel bar bent at a right angle. That layout gives users a way to apply torque to a socket attached on one end, tackling anything from stubborn bolts to delicate fasteners, depending on the socket size. Its design has remained largely unchanged for decades, which might seem surprising in a world that constantly reinvents products. Yet that's part of its charm. It's a straightforward solution to a mechanical challenge, relying on the inherent strength of steel and good old-fashioned leverage. Early versions of such wrenches date back to the days when personal automobiles started to spread worldwide, and drivers needed affordable, simple tools they could keep in a trunk. Over time, the design grew more standardized, especially after standardized sockets became widespread, with drive sizes like 1/4 inch and 1/2 inch. This simplicity also made the wrench popular among professionals because it rarely fails, and you can easily swap out sockets in a flash. That simplicity, however, can be misleading. Factories that produce L-handle wrenches typically operate massive lines dedicated to forging, machining, heat treating, and finishing steel in volumes that can run into thousands, or even tens of thousands of pieces daily. The journey often begins with enormous coils or bars of steel delivered by suppliers specializing in specific grades. For many hand tools, a form of chromium-vanadium steel is favored. It offers a balanced combination of strength, ductility, and resistance to wear. Other manufacturers choose slightly different alloys, depending on local supply costs, brand traditions, or performance targets. In any case, the steel typically arrives in large, heavy bundles, each containing lengths that can be fed into forging machines or cut to more manageable segments. Workers might test the composition and microstructure of these deliveries, ensuring they match exacting specs. If the steel is even marginally outside the standards, the final wrench could be too brittle or too soft for the job. After the steel passes inspection, the initial transformation begins. Many factories rely on automated saws or shear machines to chop the steel into pre-measured pieces, each destined to become one L-handle. At this stage, the material is just a straight rod or bar, nothing special to the untrained eye. But once these rods move to the forging station, things get more dramatic. Forging typically involves heating the steel in a furnace, sometimes up to temperatures over 1000 degrees Celsius, roughly 1800 degrees Fahrenheit. Workers or automated robotic arms feed these glowing segments into powerful machines that bend or press the steel into the preliminary shape. Because the final form is, in essence, an L, you might imagine a simple bend is all that's needed. Yet the process is more involved than just grabbing a hot bar and giving it a twist. The angles must be precise. The length of each arm has to meet exact standards, so the wrench mates smoothly with sockets. Even the thickness of the bend radius matters, ensuring that stress is distributed properly and that the tool won't snap when someone leans into it with full body weight. Typically, the forging stage also includes forming the drive head portion, or at least shaping the area that will eventually house the square drive. Some factories do this in a single automated press, while others use a sequence of smaller presses to get the shape just right. In any method, forging is prized for how it compresses the metal's internal grain structure, resulting in a tool that's tougher and more resistant to cracking. Critics of cheaper wrenches will often point out that certain low-budget brands skip genuine forging and rely instead on casting or substandard bending processes. Although casting might be more cost-effective, it usually doesn't achieve the same strength. Among professionals, forged wrenches remain the gold standard, an emblem of quality that stands up to punishing torque without complaint. Once the piece cools, the newly bent bar typically heads to a trimming or deburring area. Even high-precision forging leaves behind small bits of flash or rough edges where the metal was squeezed out of the dies. A specialized trimming press slices off these extra slivers, and any remaining sharp spots get filed or ground away, ensuring safety and uniformity. At this stage, some factories incorporate a quick test or visual inspection to confirm the bend angle is correct. Workers measure the length of each arm, the position of the square drive, if already formed, and even the surface condition. If something looks off, a piece is either scrapped or reworked. Factories aiming for tight quality control might even use laser scanners to check these dimensions before moving the piece onward. Next, it's time for machining, which refines the square drive that mates with sockets. Depending on the factory, the L-handle may travel along a conveyor line to a series of computer-controlled lathes or milling machines that precisely cut or shape the end. If the forging stage created just a rough shape, the machining station finishes the drive to exact standard dimensions, often quarter-inch, inch, or half-inch, though it could be metric in some countries. Socket wrenches demand precise tolerances so the socket doesn't slip or wobble during high-torque operations. Even a tiny deviation can cause that dreaded rounded corners effect that leaves bolt heads stripped and mechanics cursing. So factories invest heavily in ensuring that each drive meets or exceeds internationally recognized standards, sometimes set by organizations like the American National Standards Institute, ANSI, or the International Organization for Standardization, ISO. It's in this area that you'll sometimes see brand differences emerge. Premium brands will hold exceptionally tight tolerances, ensuring a near-perfect fit and a longer tool life. They'll also polish and smooth out the drive area meticulously, reducing friction and preventing minute cracks that could develop under stress. Budget brands, on the other hand, might cut corners, literally. Their drives might be a hair off or lack consistent finishing, which can cause sockets to rattle or slip. If you've ever felt the difference between a high-end L-handle and a bargain bin one, this is where that quality gap often starts to show. Still, for many casual users, a lesser wrench might suffice for occasional household chores, and the premium brands can seem like overkill. But professionals frequently stand by that old mantra: you get what you pay for. The story continues with heat treatment, a critical step for nearly every metal hand tool. Forging has already aligned the grain, but to gain the final hardness and tensile strength needed to endure punishing torque, the steel must be carefully hardened and tempered. In a typical process, wrenches are loaded into a furnace that heats them to a specific temperature, often in the range of 800 degrees Celsius, 1 end, to 900 degrees Celsius, 1/650 degrees, though the exact figures depend on the steel alloy. Then they are quenched in oil, water, or a specialized polymer solution, causing a rapid drop in temperature that hardens the material. Immediately after, the pieces often get tempered at a lower temperature to reduce brittleness, since a wrench that's too hard might crack under a heavy load. The trick is striking a balance between hardness and toughness, ensuring the tool can handle both repeated stress and sudden shock. If the factory's processes are off by even a small margin, if, say, the quench is too aggressive or the tempering temperature is miscalibrated, the tool might end up brittle or too soft. Skilled metallurgists keep a close eye on these parameters, constantly measuring hardness levels and microstructures to confirm the tool is in the sweet spot. As you can imagine, all that heating and quenching can leave the surface scarred. So many manufacturers move their wrenches on to surface finishing next. This can be as basic as sanding or buffing to remove scale, or as advanced as automated robotic polishing lines that result in a smooth, mirror-like sheen. In some factories, the emphasis is on durability, so you might see a brushed finish that hides scratches and stands up to everyday use without looking worn. Other lines take pride in giving the tool a showy shine, especially for consumer markets where appearance might matter more. It's also the stage where brand logos or size markings might be added. Depending on the brand, these markings can be laser etched or stamped into the steel, ensuring the identity never rubs off. Although this detail may seem small, it's a big part of marketing. Tool brands are always vying to stand out, and a crisp, attractive logo can go a long way in building recognition. Plating or coating typically comes after polishing. Many wrenches go for a chrome plating process that not only gives them that bright, reflective look, but also offers a degree of corrosion resistance. Chrome plating involves immersing the tool in a series of chemical baths, like nickel and chromium solutions, that layer the metal with protective coats. It's a delicate procedure. If the plating is too thick, it can flake off when the tool flexes. If it's too thin, the tool might rust prematurely. Others skip chrome altogether, opting for black oxide or phosphate coatings that are less flashy but often praised for their slip resistance and lower environmental impact. Chrome plating in particular has sometimes faced criticism for hazardous byproducts or worker safety concerns in poorly regulated facilities. Premium factories implement rigorous safety and waste management measures, while less reputable operations might cut corners, leading to controversies over environmental harm or worker health. That's another reason some tool manufacturers highlight eco-friendly plating techniques or closed-loop water systems in their marketing, claiming a greener approach to an otherwise hazardous process. Before an L-handle wrench leaves the factory floor, it undergoes final inspections. Workers, or increasingly automated cameras and sensors, check for plating defects, cracks, or dimensional errors. They might also test torque capacity on random samples by applying extreme force to see if the tool can withstand stress well beyond normal use. If it passes, it's approved for packaging. At this point, the wrenches are sorted based on their drive size, sometimes individually bagged or placed in sets with complementary sockets. Depending on the target market, you might see them in thick plastic blister packs at retail stores, or in more robust, reusable packaging for professional tool distributors. Each brand has its own style, and these packaging decisions can carry surprising weight in the marketing realm. Some brands tout eco-friendly cardboard boxes. Others highlight minimal packaging, while budget lines might rely on simple plastic wraps. Even in packaging, there can be brand warfare. One brand claiming its minimal packaging is more sustainable, another boasting about protective packaging that assures a scratch-free tool. You might think that's the end of the story. But controversies and brand battles swirl around the humble L-handle. On the manufacturing side, some insiders whisper about steel doping, rumors that certain factories use subpar steel or cheap recycled alloys to cut costs, then rely on marketing spin to claim the same durability as premium lines. Although such allegations are hard to confirm, the tool community is rife with speculation, especially when an unbelievably cheap wrench hits the market. Users sometimes post YouTube videos or forum reviews showing the tool snapping under moderate torque, fueling distrust of lesser-known brands. Meanwhile, established brands defend their track records with data on torque ratings and third-party certifications, pointing to labs that confirm their tools hold up as advertised. Then there's the ongoing discussion about forging versus casting or extruding. Purists say forging is the only method for a truly robust L-handle, while defenders of advanced casting technologies counter that modern methods can rival forging in strength if done correctly. These debates can be surprisingly heated because hand tools inspire a certain loyalty among those who depend on them daily. Another point of debate focuses on the alleged obsolescence of manual wrenches. In the age of cordless impacts and ratcheting wrenches, some wonder whether the old-school L-handle is fading away. After all, a power tool can remove or tighten bolts far faster, and a ratchet handle with a pivoting head can slip into tight spaces more easily. Yet the L-handle endures, particularly in professional workshops where mechanics appreciate its simplicity. No batteries to die, no delicate gears to break, and no complicated mechanisms that can jam. In automotive emergencies, a basic L-handle can be a lifesaver. You won't find yourself stranded with a dead power tool. Plus, for certain tasks where you need a direct sense of torque or a minimal profile, nothing beats that simple bar of steel. At the same time, innovation does creep in occasionally. Some manufacturers have tested telescoping L-handles that can extend for extra leverage, or designs that cleverly fold to save space in a toolbox. Though these new variants haven't quite replaced the classic design, they show that even a seemingly timeless tool can see subtle evolutions. Environmental discussions also play a part in the narrative. Steel production is energy-intensive. Factories that pump out thousands of wrenches daily consume electricity and natural gas, generating carbon emissions. Responsible companies invest in more efficient forging processes, advanced heat-treating ovens that recycle heat, and water treatment systems that reduce pollution. When you multiply these efforts across various sectors of the steel industry, you start seeing a bigger picture impact. Some environmental groups argue that we should reduce reliance on steel-based tools or find ways to create them from recycled metals more aggressively. Others point out that a well-made L-handle wrench can last decades, sometimes passed down through generations, making it a more sustainable choice than cheaply made tools that end up in landfills after a year or two. So while the production itself has an environmental cost, a durable, timeless design can offset that cost over time. It's yet another layer of complexity in evaluating how green a simple hand tool can be. Culturally, the L-handle wrench has a foothold in many regions. It's not uncommon to find one stashed in the trunk of a car, included by the manufacturer to assist with tire changes. In places where vehicles are essential daily lifelines, the L-handle can be the difference between being stranded on a remote road or getting yourself back on track. Mechanics in rural areas might still rely on manual tools over advanced pneumatic or electric ones, either for cost reasons or due to limited access to stable electricity and compressed air. In some developing countries, local blacksmiths even produce rudimentary versions of L-handles, forging them by hand from scrap steel. An age-old practice that reaffirms how universal this tool can be. Even in high-tech settings where you might expect automated everything, there's always a place on the wall for a reliable L-handle. That cross-cultural presence makes it an under-the-radar mainstay of mechanical work worldwide. And if you look closely at brand lineups in tool catalogs, you'll see an array of L-handle designs, each claiming some edge in ergonomics or strength. A few companies add contoured grips or rubber sleeves to improve comfort, though purists sometimes scoff at these additions, preferring bare steel that won't peel or degrade over time. Others experiment with composite materials or specialized coatings to make the handle rust-proof or easier to clean. Some high-end lines even add a swivel head or a rotating spinner at the tip for speed. While these modifications may seem small, they can create passionate followings among certain types of mechanics or hobbyists. Go to an online forum and you'll find threads comparing everything from the torque tolerance of one brand's handle to the texture of another's plating. Tool aficionados can be as discerning as wine connoisseurs, dissecting every nuance to see which piece offers the best overall performance. If all this seems overblown for something as humble as an L-handle socket wrench, consider how vital it can be when you're dealing with stubborn rusted bolts, critical automotive repairs, or delicate assembly tasks. The trustworthiness of a tool can't be measured solely by marketing claims. Sometimes that trust is built over years of use, verifying the tool doesn't bend, slip, or snap under harsh conditions. In many shops, an L-handle that's still going strong after a decade or two earns a revered status. It stands as proof that the forging, heat treatment, and finishing were done right. This is why smaller boutique toolmakers sometimes emerge, marketing wrenches that promise an almost artisanal level of care in every bend. They might charge a premium, but they back it up with lifetime warranties, and the proud statement, "If it ever fails, we'll replace it free of charge." Larger brands can't always match that personal touch, though they often match or exceed it in terms of mass production quality and advanced engineering. Delving even deeper, there's a curious interplay between standard and metric sizing. In regions that heavily rely on the imperial system, you'll find L-handles specifically labeled for 1/4-inch or 3-inch drives. In metric-focused areas, you might see 6.3mm or 9.5mm drives that basically mirror the imperial sizes. Globalization means many factories now produce for both systems, shipping wrenches worldwide. This cross-pollination reveals how a single manufacturing plant can serve drastically different markets, from the American heartland to European automotive hubs to Asian factories assembling consumer electronics. The L-handle bridging these diverse sectors is a testament to its universality. It adapts to different socket systems and local preferences with minimal fuss. But what about the future? As technology marches on, some believe that manual wrenches will become niche items in an increasingly automated, battery-driven world. Mechanics might use torque-sensing electric drivers, and everyday consumers might rely on vehicles that rarely require user maintenance at all. Yet the L-handle's story suggests a quiet resilience. Even if advanced tools dominate certain tasks, the simplicity and reliability of a solid steel bar remain tough to beat, especially in situations where technology isn't practical or available. If you're in a remote location, experiencing a power outage, or dealing with a corroded bolt that requires delicate manual finesse, you'll be glad to have this classic wrench on hand. There are also hints of new materials that could disrupt the status quo. Some research labs are experimenting with ultra-strong composites or novel alloys that combine lightweight properties with steel-like strength. While cost and manufacturing challenges keep these concepts largely in the prototype stage, it's not outlandish to imagine a future L-handle that weighs half as much while delivering comparable durability. Whether or not that's a worthwhile trade-off remains to be seen. After all, a few extra ounces aren't usually what determines a purchase decision for a hand tool, especially when that tool's reliability can mean the difference between a completed repair and a snapped handle. Of course, all of this talk about forging, brand loyalty, and future possibilities doesn't erase the fact that to many users, an L-handle wrench is just another item in the toolbox. But that's precisely what makes its backstory so intriguing. The very ordinariness of this tool masks a remarkable effort in materials science, manufacturing craftsmanship, and global distribution. Each wrench you see on a store shelf has likely undergone multiple inspections, from the chemical makeup of its steel to the final chrome thickness. It has endured punishing temperatures and mechanical presses. People worked shifts to operate or maintain the lines that shaped it. Quality control managers spent hours ensuring each batch met torque requirements. And then it was priced, packed, and shipped, perhaps traveling thousands of miles before landing on a pegboard display or an online storefront. For some, the biggest question might be which brand to trust. Should you invest in a high-end name that charges 2 or 3 times more, or settle for a no-name piece that claims roughly the same specs? Whether you're a professional mechanic, a casual hobbyist, or just someone who wants a reliable tire change tool, the answer often hinges on how frequently you'll use it and how critical your tasks are. If your livelihood depends on a dependable L-handle day in and day out, the calculus might differ compared to someone who only needs to remove a few bolts a year. But one thing's certain: the more you learn about the manufacturing process, the clearer it becomes that not all L-handles are created equal. Subtle differences in forging, heat treatment, and finishing can add up to a world of difference in practice. But what if, in the not-too-distant future, we see entire factories pivot to a new generation of automated forging presses that utilize artificial intelligence to refine each bend in real time, or advanced scanning systems that can detect micro cracks invisible to the human eye, ensuring near-perfect production runs? Already, modern facilities are embracing robotics for consistent, round-the-clock output. The role of skilled workers is shifting from physically handling materials to monitoring computerized lines and adjusting parameters. This might lower manufacturing costs and raise quality standards further, or it might introduce new variables and complexities. In any case, the L-handle is poised to follow the broad arc of industrial evolution, morphing in subtle ways, while staying true to its functional roots. And as the world becomes ever more connected, the line between local craftsmanship and global scale becomes blurry. A single L-handle might have steel sourced from one continent, be forged on another, plated on a third, and then sold in a country thousands of miles from where it was created. Considering all these threads of production, competition, and speculation, it might be surprising to realize that this essential tool started out as one of the simplest mechanical levers known to humankind. At its core, the L-handle is a testament to how effective a simple machine, a lever, can be. You're amplifying your force through a strategically bent metal rod. That concept hasn't changed since the days of ancient blacksmiths crafting rudimentary picks and nails. What has changed is the scale, precision, and complexity hidden behind every final product. From the vantage point of someone rummaging through a garage drawer, the L-handle is just there, ready to be used. Yet the moment you dig into its journey, from raw steel to shining finish, you see the finely orchestrated ballet of heat, pressure, and craftsmanship that makes a durable, trustworthy tool possible. The next time you tighten or loosen a bolt with that angled piece of steel, think about the molten metal, the roaring forge, the watchful engineers, and the quality checks that shaped it. Recall the historical path from mass adoption in early automotive days to the global presence it enjoys now, bridging different cultures and mechanical standards. Contemplate the ongoing dialogues about sustainability, forging methods, brand identity, and how each brand's approach leaves subtle fingerprints on every handle. Remember that while new inventions might eventually overshadow the venerable L-handle, it remains a go-to choice for countless tradespeople and tinkerers who rely on its no-nonsense dependability. And so, the story of how an L-handle socket wrench is made reflects not just a single product's life cycle, but the interplay of technology, tradition, and global economics. From the moment steel is chosen to the final pass of quality control, it all converges to create a tool that seems deceptively plain at first glance. In reality, it's the product of countless decisions, small innovations, and a drive to constantly refine that ancient principle of leverage. While it may never dazzle in the way a new smartphone or electric vehicle might, the L-handle's quiet legacy and unyielding reliability stand as a reminder that sometimes the greatest engineering marvels are the ones we barely notice. If you listen closely, though, you'll hear the clang of the forge, feel the pulse of the assembly line, and grasp the subtle artistry underlying each bend in that timeless bar of steel.